Okay, so this week's video is on a question that's fairly simple, but what actually happens as a computer boots up? It's not a question that matters a huge amount normally, but when something's going wrong with your computer, or when you first built it, or when you're writing certain types of software, which most academics are unlikely ever to write, but if you ever do write bootloaders or operating systems or similar things, you have to worry about it. But it's one of those things that's just useful to know so that you can diagnose problems, get a general understanding of how computers work, and things like that. Now, this is essentially going to go through the booting sequence of a computer, and I'll talk about bits as we go through. And the most important thing to note is that what I'm going to be talking about here is primarily a normal computer. Now, you'll actually see I'm going to demonstrate this with an abnormal computer, because otherwise I'd have to have a computer set up here somewhere with a camera pointing at it. But all of the elements of it are the same as a real computer. What I'm not going to be talking about are servers. Dedicated servers nowadays actually quite often are two computers stuck together. There's the actual computer that does the work, and there's something called a BMC, or baseband management console, which is another much lower power computer that can actually run even if the main computer is completely dead. So there are terms that are connected with how computers work and how computers boot up that we're not going to be mentioning here, but I'll try and mention pretty much all of the other terms that you're likely to come across. So first of all, we have this screen. So this screen gives away the trick of how I'm recording this video, which is on a virtual machine. Now, virtual machines are a way of running one operating system inside another operating system, but they do that by effectively simulating a computer inside, and they have most of the same parts that a real computer does. So what we're looking at here is what is generally called the BIOS screen. Now, BIOS stands for Basic Input-Output System, or Basic Input-Output Subsystem. There's no complete agreement on what most of these terms mean, because different manufacturers use slightly different versions. But essentially, this is the first screen you will see when the computer turns on. So what you are usually seeing on this screen is either a logo, like you have here, or you may just have text. Part of this system is what's called the power on self-test, or POST. So that's another acronym that's very worth knowing about if you have problems with a computer, because if something is said to fail to post, it is failing this power on self-test, and that usually means there is something fairly fundamentally wrong with the computer. If the computer's been working well for a while, you may need to reseat things, but there's a chance that something has gone seriously wrong. If it's a new machine you're building, failure to post usually means you haven't built it quite right. Few other points to note. This is usually still called the BIOS screen. However, technically, most modern computers use a related but different system called EFI, or Extensible Firmware Interface. Does the same job. Its job is to run the really low-level bits that get a computer started so that it can start moving towards booting up. And usually, an important thing to note is you will have here down at the bottom, I can't indicate with my cursor because this is from a bit, oh, I can, yeah. So this bit here with the cursor here, press F12 to select boot device, and that's selecting which of the computer's hard drives it's going to boot from. So I will actually just unpause this and press that, and you'll usually get a screen that looks something a bit like this, and it'll tell you what the options to boot from. So in this there's 2 hard drives, and usually it'll say about a floppy drive because it can't detect a floppy drive. Sometimes it can't detect the CD-ROMs, it'll give you that option, and boot over LAN. Booting over LAN is a really useful thing to be able to do, but it's a bit specific, so not really going to talk about this at all. The important thing to note is that at this stage, what's really still running this is this BIOS system. What I'm going to do now by selecting a boot device is I'm going to hand over to what's called the boot loader. So the bootloader is the next stage, and that is a very small system that's at a specific part of the hard drive that the BIOS system knows. I go there, I run the code I find there, and the system starts booting. So here we go. This is now actually booting because this machine is set to just boot straight up into a working machine. And before I upload this video, I'll have to go back and make sure that nothing at all personal is in that text that scrolled through the screen, but usually there isn't. It's pretty safe to show this. But what I'm going to show you when this system has booted is the bootloader itself. So this machine is configured to have one operating system and to boot straight through into that operating system. The bootloader in this case is trivial. It literally just goes, okay, I've started the basic system, I've started the rest of the hard drive, I'm now going to load the rest of the operating system. If you have a more complicated system, or if you particularly have two operating systems installed on one computer, something that's generally called dual booting, you will see another screen. And the screen you'll generally see, because most dual boot systems are Linux systems, is a system called Grub. And I will just pull up the Grub Loader in Wikipedia because I can't easily show it on the actual system. And that'll show you what that quite often looks like. Okay, so here we go. GNU Grub, which stands for, as it says here in Wikipedia, the GNU Grand Unified Bootloader. And what you'll typically see is either something that looks like that, where you move something up and down on a command line. This here is running in a different thing called QEMU, which is an actual emulator rather than just a virtual machine. And they probably have here... No, there are other versions of Grub bootloaders that are a bit more graphical than that. And so that's the bootloader. And then the final stage, as I say, is loading the actual operating system. And that's basically it. Once you're at this stage and the operating system is loaded, you're in and everything's working. The key thing where this is important is, as I say, usually when something goes wrong, in which case what you want to do is identify at what point it went wrong. Did it go wrong because the system failed to post? Did it post but it couldn't find that bootloader? Did the bootloader start but it can't load the rest of the operating system? And that's sort of the key question you want to work out. And it's not always obvious. Now, unfortunately, I can't easily show it because it's actually not a trivial thing to set up a system that is designed to fail in reliable ways. But that's the key thing. I think just before finishing this video, the last few things to talk about are a few terms that I haven't mentioned that are potentially rather important. Now, this system had paused on that initial BIOS screen, as I called it, for quite a long time, because if you press the pause key on your keyboard, if you've got one, the computer will stop at the BIOS screen. I will say this is something I really should have mentioned earlier, but this is all based on commercial off-the-shelf x86 hardware made by normal PC manufacturers. If you go into more esoteric stuff, certainly if you go across to Apple Macs, things look different, although actually the same stuff's happening behind the scenes, but it looks very different. Or if you go across to IBM Power or Open Power or to ARM-based chips, things can look different, but the concepts are very similar. It's just what you see on screen tends to look quite different. But yes, so I'd paused the BIOS screen so I could show you it. But in actual fact, quite often on a lot of machines, that BIOS screen can stay up for a fair few seconds because they want to give you time to hit F12 or whatever the correct key for your system is, to start that boot menu that I showed you, or to go into the BIOS setup screen, which allows you to change low-level parameters about the system. They want to give you time to interact with it. If you go back to even older machines, then you would actually sort of see the thing counting through all the memory as it checks the computer's memory is there, and that could take a few seconds as well. So a few years ago, something was introduced which is called Fastboot, and the whole idea of Fastboot is the system goes from post straight to the bootloader. It doesn't give you time to go into that boot menu. It doesn't give you time to go into the BIOS setup screens. It doesn't give you time to do quite a lot of things. And the important thing about Fastboot is it can be very annoying if you do want to go into a boot menu, if you do want to go into the BIOS setup screen. And unfortunately, the only way you can reliably turn that off is either to be able to go into your operating system, in which case, for most operating systems, there is just something you can do when you shut it down to say, next time, don't fast boot, show me that BIOS screen and leave it there so I can interact with it. Or, based on the exact system you're working with, there will be some other way of turning fast boot off. Pretty much every system I've ever encountered. So that's Fastboot. It's very useful. It gets you into your operating system faster, but when you do want to do something unusual, it's something you need to know about so you can bypass it. So that may be why you've booted your computer and never seen that BIOS screen. It'll be there somewhere. Another thing that crops up, because it's an old term that's still rather in use, is what's called Cmos. In particular, quite a lot of motherboards, if you look at them, have a little round button cell battery on them, and that is still, to this day, typically called a Cmos battery. Now, quite a few people who watch these videos I know are physicists, and quite a few of them will have, typical physicist background. So if you've done anything on electronics, you will perhaps have come across the term CMOS, meaning complementary metal oxide semiconductor. And this is where you'd expect me to tell you that that's not relevant, it's a different acronym. It isn't. That is actually what CMOS stands for in computers. A historical reason is because CMOS, as a way of producing transistors, produces transistors that have a very low power draw, particularly when they're not actively switching, which means if you're going to have a little battery-backed system which holds this BIOS, CMOS electronics is a really good way of building that system. And given that when the term first came into use, the older NMOS system was mainly used for the rest of the electronics on a computer, the bit that did this, battery-backed store the basic input-output system was called CMOS by a lot of people. So it's just a historical thing, but that's another term you'll sometimes hear. So that's an important thing to remember. If someone's talking about CMOS, BIOS, or EFI, they're effectively mostly talking about the same thing. I think that pretty much covers all of the bits about booting a computer, so I'll end the video here.